Hey there, everyone, Alejandro, and welcome back for day 305 of me doing the Daily LeetCode challenge after I reach 1 year's worth of green contributions here on GitHub. So today's problem is from May 17, 2025. Without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 75, sort colors. Seems like we've solved this problem before. Oh, okay, there's no, okay. So we saw this before, but I saw what I thought was code here, so I immediately went for the refresh. Okay, when did we solve this? June 30th, 2024. So this was one of the practice problems I did before I even started the Daily LeetCode Challenge series on YouTube. Okay, pretty cool. So, given an array nums with n objects colored red, white, or blue, sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. You must solve this problem without using the library sort function. Okay, well that's annoying. So this is annoying, right? Because usually when I don't like these types of problems. You must do it in place, which is kind of like, is quicksort in place? So really, when I think of sorting, like, I only really know merge sort, right? Or at least in terms of theoretically O of n log n time, right? Something like quicksort can technically be O of n squared, and then like wobble sort, insertion sort, all this, and well, in this case, insertion sort is kind of useless. But all these other algorithms that I know are not necessarily n log n. I know there's many O of n log n sorting algorithms, such as merge sort, but to do it in place in n log n, is there a sorting algorithm to do that? Because then, like, what would be the point of merge sort, right? Because if you can do it in n log n exactly, not like, always, not like, most of the time, like in quicksort, exactly O of n log n and O of one extra space, that'd be pretty cool. It might exist. I should just do a quick lookup. It's just not something that I know of at the moment. So, obviously one way to do this is nums.sort. Actually, wait. This is just super easy. What am I talking about? We can do this in O of, like, we just do red, white, blue is equal to 0, 0, 0, right? This is constant extra space. Surely this is okay. Okay, like some variables outside should be okay, right? Here we'll say, for num and nums, we'll say red, white, blue. So 0, 1, and 2. Here we'll say equals reds plus or equal 1. L if num equals white plus or equal to 1. Else assert that num equals blue plus or equal to 1. Right? And then we'll say for I in range length of nums, we'll say if red greater than 0, then red minus or equal to 1, nums of I equals red, and continue. Otherwise, elif blue greater than 0, nums of I, wait, so it's red, white, blue, right? Red, white, blue. So here we want to do red, white, blue. So red, white, and white minus or equal to 1. Else assert that blue greater than 0, nums of I equals blue minus or equal to 1. Right? Assert red equals white equals blue equals 0, return nums, right? So something like this is technically O of n squared, and I've sorted it quote unquote in place, right? Red, white, blue is equal to, not double equal sign, that's my bad. Okay, that's accepted, and now let's submit. And And there we go. Completion streak 305 days. Consistency is key. See ya tomorrow. Okay. I got a little worried because I was like, okay, how are we gonna do this? Does it have to be? Yeah, n is 300, so you could really just do something like bubble sort. But I was like, for sorting, I don't ever want it to be like, slower than n log n. So it's like, if you don't want to use a library sort function, right? I could have written something like bubble sort or insertion sort. That would be technically okay. Or not insertion. Is insertion sort where it's like, you have an array and you like spend O of n time like inserting an element, but that way it's just like always sorted. Or is it just like an actual algorithm for sorting array? It's not something I actually know. But when it comes to sorting algorithm, I just know how to implement merge sort, and I've just never really bothered learning anything else, right? Besides like quick sort, because quick select is like oftentimes it's like can be useful, even though it has a theoretically worse complexity. Just it's like in case you get the array in like reverse sorted order, yada yada yada. But yeah, but something like merge sort, while it's n log n, it is not in place, right? It requires linear extra memory, right? With O of n log n time complexity. But here we were able to actually solve it in O of n time with O of 1 extra memory, right? We didn't. They said to do it in place, right? Yeah, what does in place mean? That operates directly on the input data structure without requiring extra space proportional to its input size. In other words, it modifies the input in place without creating a separate copy of the data structure and algorithm. Yeah. Can only have a constant amount of extra space. Okay. So we solved this problem correctly. So we used constant extra space, and now we have an O of n solution with O of 1 extra space. Okay, so nevertheless, as always in all my videos, I do a quick recap if I will solve a problem. So for this one, we're supposed to essentially basically, you can forget the colors. We are basically given an array of zeros, ones, and twos. 0 really maps to red, red, 1 maps to white, and 2 maps to blue. And so essentially we want to sort the array with all the zeros at the front, then all the ones, then all the twos. And so the only restriction to this problem is that you're not allowed to use any library sort function, right? And you're not allowed to use any extra space. So you must solve this in place. Now, I clicked on this link, which is this Wikipedia article here, and it says the algorithm can only have a constant amount of extra space, which is exactly what I've done. I do use extra space on top of nums, but it is constant in terms of asymptotic complexities, right? So here, this is the constant space I'm talking about. I store 3 variables, red, white, and blue in capital letters to represent the numbers 0, 1, and 2. And then I store 3 variables, lowercase red, white, and blue, to store the frequency of each color, right? So in nums, they're all the elements are either going to be red, white, or blue. So we want to essentially count how many are red, how many are white, and how many are blue. So for every single number in nums, we're going to say, okay, if the number is red, then increment the number of reds that we've seen by 1. If the number is white, increment the number of whites by 1. Otherwise, assert that the number is blue and increment blue by 1, right? Then what are we going to do? So we have the frequency of reds, whites, and blues. Since we wanted to quote-unquote sort it in terms of reds, whites, and blues, we can essentially just update nums to just have red, many reds, this many reds at the front of the list, followed by this many whites, followed by this many blues, right? You can't usually do this with regular sorting out algorithm, just because, because you might not have necessarily a constant amount of unique elements, right? In this case, we only have 3 unique elements, right? So we can easily sort it by keeping track of the frequency of the 3 elements and then plugging them in that sorted order, right? So here what we're going to do is we're first going to put in all the reds. So what I'm going to do is I'm going to loop through every single index in nums. I'm going to say, okay, while I still have red balls, or whatever, I think these are numbers. So while I still have some that are red, sorry, just muting my phone there. As long as I have any that are red, let's put red balls, right? So that way at the beginning in the season, I'm going to keep putting red balls until I'm out of red balls. So if red is greater than 0, then I'm going to say nums of I is equal to red and subtract the number of red balls to put by 1, right? Eventually, as I go through nums, eventually red will be 0, right? I'll have placed all the red balls I wanted to. So now it's time to place all the white balls. So then I'll say, okay, every single time I'll skip this statement from now on. So here we'll say, otherwise, if white is greater than 0, right? If we still have, more than 0 white balls to place, let's keep placing white balls. So nums of I is equal to white and subtract the number of white balls left by 1, right? And keep on going until we reach 0 white balls, in which case we'll have nums be a bunch of reds followed by a bunch of whites. And now in the rest of the for loop, we'll get into the else clause. Here I'm just asserting that the number of blue balls is greater than 0, since we still have to place a ball because we're still in the for loop, but there's no more red, there's no more white, so assert that we still have some blues, right? So nums of I is equal to blue and subtract the blue count by 1, right? Then at the very end, I'll just make sure that red, white, blue are all equal to 0, just a little assert because I'm paranoid, just to make sure that we put in all the reds followed by all the whites followed by all the blues, and then we just return nums because we updated all the indices of nums to have red balls followed by white balls followed by blue balls in respect to the counts that we initially got from the beginning of the function. And but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and any shape or form, I'd highly appreciate it if you left a like or a comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye-bye.